The second method that we've seen to solve a system of equations is by substitution. So here's an example. We have two equations. The first one is in blue here, minus 2x plus 3y equals to 8, and the second one, 3x minus y equals to 5, is in red. We're going to just give them names, so I'm going to call the blue one equation 1, so I have a 1 with a circle around it, and the second one is equation 2. I can choose either of the two equations. You should choose whichever one is easiest. So here, because the y is already alone, it's easier to isolate the y in equation 2. We could have chosen x also. In this case, there's a negative 2 in front of the first equation and a 3 in front of the x in the second equation, so that's not the easiest. So the easiest thing is to isolate y in equation 2. So we're going to do that. I want to get rid of the terms with x and put it on the other side of the equation. So I subtract 3x on both sides of the equation. And I'll be left with minus y equals to minus 5 minus 3x. To get rid of the negative in front of the y, we divide every term in the equation by negative 1. So we're left with y is equal to 5 plus 3x. That's still equation 2. We've just changed the way it looks. So I'm going to give it still the name 2, but 2t. T is for transformed. So we just transformed the look of equation 2. Now if we move on, what we can do, and this is the name of this method, is substitute this equation 2t into equation 1. So the equation 1 was minus 2x plus 3y is equal to 8. So y, as we see in equation 2t, is now 5 plus 3x. So I replace the y by 5 plus 3x. Now we're going to expand the terms that are inside the bracket. So I have minus 2x. 3 times 5 gave me 15. Okay, so this, we multiplied the 3 here times 5, and that gave me 15. And then 3 times 3x gave me 9x. And that's equal to 8. Now what we want to do is bring all our constant terms to the right and keep our x terms to the left of the equation. So we're going to get rid of that minus 15 on the left side by subtracting 15 on both sides of the equation. So we'll be left with minus 2x plus 9x equals to 8 minus 15. Okay, so that's going to give me 7x is equal to minus 7. I want to isolate the x. That's the goal here. So we divide both sides of the equation by 7. So I'm left with x is equal to minus 7 divided by 7, which is x is equal to 1. So we're just going to highlight this. This is part of my answer. We're going to save it for later. Now we need to use the x is equal to 1 that, x equals to negative 1 that we just found, and we're going to substitute it into any of the equations. It doesn't matter. The easiest one is 2t, okay, this one over here, because we've already isolated the y in 2t. Okay, I want to find a value for y now. I found x, I want to find y. Here, y is already isolated, so it's the easiest method. So I substitute it in there. Okay, so my 2t, my equation 2, which is this equation up here, and t, because it's transformed, I just changed the look of it, was y is equal to 5 plus 3x. So remember our x is minus 1, so I substitute x is equal to negative 1 in there. So we're left with y is equal to 5 minus 3. That gives me y is equal to 2. And that's the second part of my answer, and we're done. So we can say, therefore, the point of intersection is 1, 2. I shouldn't say the over here. The point of intersection is negative 1, 2. Okay, and that's all.